It's really important to specify the correct components which make up the topology of an SDVoE system. As industry professionals, we're very familiar with a matrix switch topology, and this course will compare the differences between the two. You'll be introduced to the various components of an SDVoE system design, which in turn will give you much more confidence when demonstrating the flexibility and scalability of SDVoE to your customers.
Throughout SDVoE training, we often reference the typical topology of an SDVoE system, comparing it to that of its matrix switching counterpart. This course will dig a little deeper into this topology and identify each component of an SDVoE system, from control to hardware, and help you understand just how flexible and scalable this technology is. At the heart of a matrix switch system is, well, a matrix switch, and it's this piece of equipment which has long been the driving force behind video distribution. In all fairness, it's done a very good job of it. Not surprising really, because almost every penny of research and development has gone into making this big chunky box deliver perfect image quality from source to display. Unfortunately, R&D is expensive, and as image resolutions get bigger and the demand for perfect latency-free video distribution grows, more and more money needs to be spent making sure the matrix switch can deliver it, and this makes each port more and more expensive to buy. As development costs spiral out of control, fewer and fewer manufacturers are able to keep up. Designers are stuck with only a few choices, and system owners end up locked into a single vendor for their entire system. Functionality also plays a major part in the cost of a project. If features such as video walls or multi-view applications are required, a traditional matrix switch is unable to help. So, extra equipment has to be added, which further adds to the cost. With more equipment comes more control complexity. It takes a lot of programming and testing to ensure the correct output on the matrix switch is selected prior to the multi-view processor selecting the correct sources to be presented within the display, or check the video wall processor is pushing the correct image from the matrix to the correct display. So, how does SDVoE make all of this less complicated? Let's begin by swapping out the matrix switch for an Ethernet switch. Like matrix switches, Ethernet switches also need research and development, but unlike the thousands of matrix switch ports available, there are tens of millions of Ethernet ports available to us, and that makes them an awful lot cheaper to buy. There are also a huge amount of companies developing Ethernet switches, so in Pro AV, we don't need to worry about them too much, allowing us to focus on the sender and receiver units which use SDVoE technology.
So every port is bidirectional in an Ethernet system. It can be an input, it can be an output, or it can even be both at the same time. Trunk ports on Ethernet switches mean it's very easy to cascade and scale these systems from simple little 6-port or 8-port devices up into hundreds or thousands of ports in a single routing system. And then, of course, by jumping from a sort of purpose-built proprietary matrix switch architecture into the world of IT switching and Ethernet infrastructure, we get to enjoy Moore's Law and the price curve that comes with that. That means that the cost of our systems can now fall, cut in half every 18 months, as we expect from high volume computer and communication electronics. Every enterprise customer that you already has an enterprise class Ethernet infrastructure installed. So we no longer have to have a conversation about, let's install this new technology, let's install a dedicated switch for your video management. And instead we can just have a simpler conversation about expanding their existing network infrastructure to be able to meet these new use cases. So why can we do it now, right? This all sounds great. Why haven't we been doing it for years in Pro AV? And there have been three sort of fundamental drivers holding us up, all of which have now been overcome. The first of those is bandwidth. You can imagine that video signals do require a ton of bandwidth to maintain their quality. In fact, if you look over the history of Ethernet communications and video communications, we're actually at a very interesting point in that history right now. And that's the point where the mainstream Ethernet bandwidth available, and today that means 10 gigabit per second, is actually greater than the mainstream video formats that we need to transmit today. So let's look back at the past. If you rewind 10 years ago, we were thinking about 720p, we were thinking about 1080i. The bandwidth of those raw video signals is around 1.5 gigabits per second. And yet the commodity Ethernet technology available was only 1 gigabit per second. So it didn't quite fit. Go back 20 years ago, imagine a digital VGA. That signal would take 400, 500 megabits per second, and yet it wouldn't fit on our 100 megabit per second Ethernet. Today, 10 gigabit Ethernet is ubiquitous, and that is sufficient to carry the 1080p signals, the 4K signals that we require in a high-performance video system. This trend is only going to continue as Ethernet data rates become faster and faster. And although video rates will do the same thing, we can now trust that there will always be space on our Ethernet network to manage the signals that we have. The second thing that's held up this transition until now has been cost. I talked about needing a commodity-level Ethernet technology to solve this job. Right? So 10 years ago, in 2007, a 10 gigabit Ethernet port was available only on fiber optics and would cost you around $1,200 per port. So you can imagine that leads to very expensive systems. And yet today, 10 gigabit Ethernet is available on copper, it's available on fiber, and you can literally go on Amazon.com and buy a 10 gigabit per second Netgear switch for $80 a port. And I'm talking with free prime shipping, not even a big enterprise level customer making large bulk purchases. This stuff is very cheap. That compares to your HD-based T-switch, the dedicated circuit switch system, where those costs can run up to $1,000 a port. And guess what? Those switches get more expensive over time, right? It's very expensive for a matrix switch manufacturer to develop a new higher speed product. And so you've seen, as we've transitioned from 1080p to 4K to 4K 60, the price of matrix switches are going up. Meanwhile, in that time, the price of 10 gig Ethernet is still falling at around 35% a year. And the final piece of this puzzle is we need a technology to deliver audio and video signal across an Ethernet network. The fundamental challenge is that audio and video, as we talked about earlier, are synchronous signals. Timing matters deeply to these signals' functionality. This is why doing it on a circuit switch is easy. However, Aptovision have developed a new technology called adaptive clock resynchronization that allows a synchronous audio-video signal to pass through an Ethernet network and then become reconstructed on the other side with exactly the timing that came in. We're actually reconstructing the clock that came from the data source, the video source, on the far end. Now, this is the breakthrough that makes it possible to say that we can replace the matrix switch with Ethernet networks.
Now let's turn our attention to the endpoints. In SDVoE, the transmitters, or TX units, are often called encoders because they use codecs to turn audio, video and control signals into data packets. Receivers, or RX units, are often called decoders due to their ability to turn those data packets back into their original AV or control signals. However, unlike a traditional receiver unit which attaches to a matrix switch, an SDVoE receiver or decoder is capable of far more. The transmitters and receivers are capable of processing HDMI all the way to a full 4K 444 resolution at 60 Hz. Both HDCP 2.2 and 1.4 are supported, as are HDMI audio formats such as Dolby Digital AC3, Dolby True HD, Dolby Atmos, and DTS, as well as analog 2-channel audio. Control data can also be sent across independent multicast streams, such as IR, RS-232 and USB 2, and each endpoint provides a 1 gigabit Ethernet port for local peripheral devices. Whilst they're both able to receive multiple signals from a transmitter, the SDVoE decoder can also become a video wall processor or a multi-view processor, all from a single command sent by SDVoE control, something you would struggle to achieve with the controls on the front of a matrix switch. So where does all this control actually come from? The answer to this is easy: software, more specifically an application programming interface. Put simply, this is a set of commands which can be used by any control interface to tell the transmitters and receivers what they need to do or how they should behave. Because we are using Ethernet to transport the data packets, all we need to focus on is talking to the transmitters and receivers in a common language which they all understand. And this is the job of the API. There are a number of ways this can work. A popular choice amongst SDVoE manufacturers today is to place this software onto a dedicated small form factor computer which lives on the same network as the transmitters and receivers. This computer then allows any third-party interface to control the endpoints. You could think of this software as the buttons on the front of a matrix switch, but because it's driven by software, it's far more powerful. Not only that, if you need to add more endpoints, you can. You don't need any more computers, you just need to make sure you have enough ports on your network. So unlike a matrix switch, which can only accept a limited amount of endpoints, an SDVoE system can accept as many as the highly scalable Ethernet network can support. And the Pro AV industry doesn't need to spend millions of pounds finding more bandwidth for the future, because our networking allies are taking care of that for us, meaning we can focus on making SDVoE technology drive the future of video distribution and cement its place in Pro AV as the matrix transformed.